We have a wonderful month. We have enough planets to keep us happy, and other very lovely, a lot of them deep sky objects that you can really enjoy with either binoculars or telescopes. And just to start right off, when I was asked to do this, maybe about 15 years ago, I was nervous. I thought, well, now I have to have something ready every month. And it just turned into this really nice thing where I sit and look for gorgeous pictures on the internet that I can copy and paste for you, and stories about what's going on in space. And it's really turned out to be, I'm retired now, so it really sets off my schedule very nicely. You have to learn how to say no, but I've got a lot of hobbies and I'm very happy. So there's your little beach scene. And first, we're just going to do recent space news. Some of this has been showing up in the regular media, so this may be helpful to you. First, we got something that's got to wake up. On June 23rd, New Horizons had safely awakened from a little under a year hibernation period that began in 2025. Now it's about 5.9 billion miles, and it's going to begin or continue to transmit science data gathered in the distant Kuiper Belt far beyond Pluto. So it's marvelous that it wakes up when we want it to. And again, that was in the news quite a bit. And on the other side, CERN has shut down, going to sleep for a while, and it's they're going to dismantle part of the accelerator. And if you want to Google it and get all the terms that are really hard to understand at first glance, but they're going to install the new high Lumi LHC equipment. And it's now not going to be just the LHC, but the high Lumi LHC when it comes to fruition in about 4 years. There you have it. We also want something to stay up where it is, and this is again in the news. NASA has just launched a Swift, really a boost mission to rescue a space telescope. The Swift Observatory is one of those space observatories that is looking at gamma rays and telling us an awful lot about the beginnings of our universe. And actually, this was the headline from the Times a few days ago. And this is an artist concept. I love it. It's actually the observatory being ferried to a higher orbit over Earth, because its orbit is falling, which happens to a lot of space, not junk, but important missions. And unlike a lot of other missions, the Swift does not come with sort of an automatic booster, something that can repair it and keep it where it's supposed to be. So we literally have to send a boost. The startup Catalyst Space Technologies Link spacecraft, there it is. We're going to show you some real pictures, but this is a good artist concept. Apparently, Catalyst got the job from NASA, and then got in touch with Grumman, and they were saying, there were these wonderful rockets called Pegasus rockets. It's only about 26, 27 of them made, and they used to be able to do this. And I'm going to show you how amazingly they use this rocket. But Grumman apparently said, you know what? In storage, probably bound up in, what would you call it? Shrink wrap, is one left. Should we use it? And they used it. So basically, it's going to, of course, it adheres to their observations on July 3rd. Northrop Grumman, I guess that's what it's called now, is called the Pegasus XL rocket, dropped from the belly, listen to this, of the L-1011 aircraft Stargazer at roughly 40,000 feet, pretty high, above the Marshall Islands at 4:36 a.m. Eastern Daylight Time, delivering the Link spacecraft to orbit. And this is actually, they could have redone the entire thing and then had a launch and spent billions of dollars and probably taken 2 years to replace it. And they said, you know what? We can actually send a rocket on this aircraft and it will take off. So I just thought, as I said, you can read more, but I was blown away by the whole story. It's capable of, as you can see, delivering up to 100,000 pounds into low Earth orbit. And this is just a nice little diagram of how it will go. Here we've got the Marshall Islands, and it's driving, it's swiveling a little bit, and it drops its load. And the actual Link spacecraft will find the observatory and push it, and then the good old spacecraft will return to base and continue doing wonderful things. In terms of what's going on, generally speaking, I'm going to just get rid of that. One of the things about the sun being either very far or very close to us, one of the dichotomies is that we would think that we are closer to the sun in the summer, July, than in January. But as it turns out, and this is past Monday, July 6th, we were actually farthest away from the sun for the year, which is very cool. And the fancy word for that is aphelion. You've heard perigee, apogee. That's really about the moon. Same thing. That the moon and the sun. What orbits? I'm sorry, the moon orbiting around the Earth, and then us orbiting around the sun. Not in a perfect circle, in an ellipse. And at some points, we are a little closer than others. So here, well, the distance. Yeah, it's a 3% difference, but it's a difference. Okay, so that's very cool. And likewise, around January 6th, we are closest to the sun, and it's the tilt. It's really the tilt that does it, not where we are in space. Okay, so there you have it. And we've got planets. We've got Mars, and we've got Saturn. And this is sort of a view of the night sky, after midnight, approaching dawn. And Saturn's up first. And actually, we'll show you later, Neptune is nearby, but Saturn is something that you can see easily with telescopes and even with a good pair of binoculars held very steady. You can make out the rings. But Neptune is something you need a little more equipment for. And then coming up later, just an hour or two before the sun, is Mars and actually Uranus. That's another object that you can see in binoculars. It's marvelous in the telescopes. I had been at least for 10 years here before I actually saw Uranus in this telescope. And it was great because a lot of things like Mars, it looks like a white disk. For example, Mars, because it's the red planet, it looks the coolest with the naked eye. So we're going to talk about that a little later. But Uranus is actually the tiniest little dot, but it's green in the telescope. Sometimes you don't get colors. So it's really great. I have never actually caught it in binoculars, and I have, some good pair of binoculars, but in instances like this where it's going to be right next to Mars, when you know where it's going to be in the scheme of things, this time I am really going to try to get up early and see, because you should be able to see the color. You know, it will be small. But anyway, this is worth getting up in the middle of the night. It's very peaceful. I used to love to do that. I don't do it so much anymore, but the thrill is still there. And we're going to talk later. Saturn is going to ease and come up earlier and earlier so that by the end of July, we'll be able to see it right after midnight, which is very exciting because there are some planets that people love to see, and Saturn is one of them. It's like, when is it coming back? This is a good description of the, in the middle of the night sky. And as you can see, over here would be the sun coming up, okay? When you look at maps, by the way, it's a little, sometimes you have to read the directions because you're doing basically is a dome, a half circle over your head, and it's on a flat piece of paper. They usually tell you, how to hold it over your head. East for here, this is actually west, standing here in the classroom, and then this is east. But if you can, get used to how these maps go, there's just before the sun rises, you see Mars and Uranus over there on the left. And I can't really use my pointer. The people at home aren't going to see that. So I'm just going to say it's halfway down and to the left. And that they will be in the constellation Taurus. And you can see the little green Uranus there, which is cool. So to see two things that have unusual colors to the naked eye is really interesting. And then earlier, because they're already over here, having risen, first coming from there and now about, the sunrise is about 5:29 to 5:51 throughout July. This is probably about 4 o'clock in the morning, okay? So it's enough time that it's not blotted out by the sun, but the sun's coming. So, you can see Saturn and Neptune. As I said, Neptune would be very hard to see without a telescope. One other thing about the sky, and I'll repeat this later, is if you can see, there's this trail. Here's Taurus, Aries. These are Pisces. These are constellations you kind of know about because they're zodiac constellations, not some that you've never heard of. This is Aquarius. This is Capricorn. And actually, planets, when they appear, they will be in that arc. They will be only in the zodiac constellations, which makes it kind of easier to learn the sky if you know that you're not going to see anything up north by the Big Dipper. The planets just don't go there. Just because of the way our solar system is built, it's all in the same plane. Same thing at night, but obviously this is in the morning. But I love that because then when you've got you've got Hercules, you've got Cepheus, you've got I'm trying to think of Cygnus, you've got Aquila. Those are not familiar constellations because they're not zodiac. Hence their place in culture, in mythological whatever. But it's kind of cool to realize that that's where you're going to find the planets, and that helps you find your way around the sky. Because as I said, this is east, this is kind of south. So the ecliptic, which is that arc where the planets and the zodiac constellations are in, it's like the sun's path. And that's what makes it so prominent. Sun rises in the east, sets in the west, as do the seasonal constellations. And the zodiacs are a little south of overhead, but it's sort of like this. So that is where you're going to see the planets. Now, I want to mention when there is a half moon or a crescent moon, earthsky.org, as you can see down at the bottom, they usually will show you where the planets you're looking for, let's say Saturn, um, are near particular phases of the moon, and it's very pretty. It also helps teach you where Saturn is because it is like sort of a bright star, but not terribly bright. It's not like Jupiter or Venus that are so bright. People say, what is up there? It looks like a plane until then you see all the yellow and green lights, or I'm sorry, red and green lights, and realize you're looking at a plane. But to find a planet correctly, it helps to know that July 7th and July 8th, you've got some phases of the moon. Now, Saturn, as I mentioned, is going to return to the evening sky at the end of July. So, really, at the end, you could start even about 11:30, and it's going to rise. It's going to rise above the horizon, pretty well. But if you know a place where you look for things rising in the east, that's just marvelous. So, do so. The other thing about Mars, as I said, Mars and um, let me see, Mars and Uranus, which is not shown here. This is again in mid-July, the 12th and the 13th, another really neat phase of the moon when it's crescent like that, and you can see it's lit up with the white part, but it's also kind of lit up on the other side. And we call that earth shine, that it's shining enough so that you can kind of see the whole moon. And I remember once last year I stayed up all night with some astronomy friends, and the crescent moon was rising. I was waiting for other things, but I said, oh, here it is, I might as well wait. And I'm waiting and I'm waiting, and it's in the mountains, and then I can see kind of brightish round globe, and then like a fruit tree, like in the middle, which would make a very good picture. I didn't take a photo. I figured I want to enjoy it myself. But then the funny thing is that the crescent lit thing hadn't come up yet. It was just amazing. And then when it did, I was using binoculars, and it was just really bright. It wasn't dangerous bright. You can't look at the sun with binoculars, but you can look at the moon. And that's when I realized how gorgeous crescent moons are. I mean, it was just one of the prettiest moons I ever saw. So again, July 12th and July 13th, it's low enough. You see, the moon is low enough that you're going to get that earth shine. When it's higher, you don't see it. You just see the crescent. So that's a wonderful thing. You can also log on to earthsky.org and see these examples yourself. Now, our evening planet, as you probably know, is Venus. It's going to be about 15 degrees all month. It'll be high up enough. You do want to make sure that you've got a decent horizon, but it isn't something that is so, in the trees, you're only going to be able to see it. But it happens to be in the constellation Leo, and you can see Regulus right there is the main star. It's the first one that shows up in the constellation. And most of the constellation is Leo the lion, and actually looks like a backward question mark here. So it's going to be right there. And it's just really, it's just gorgeous. Again, because it is between the sun and us, you don't see the whole Venus. The Venus looks like kind of the moon. Sometimes it's a half. So that's kind of cool about Venus when you really get looking into a telescope about it. So you'll be able to see that all month. Again, the Earth Sky does tell you some cool things about the fact that the movement during the July, first Regulus is up top and Venus is in the bottom, And then, oh, July 9th, that's actually tonight, very close. And then Venus stays, it goes a little farther up, and Regulus is kind of all these constellations every day, they kind of sink after they're going overhead. But Venus is kind of on its own timetable. Again, July 15th, that is going to be gorgeous if you could really get to, this is in the evening now, not in the morning. If you could get to a very low horizon, we see the little trees there, we wish. But anyway, that should just be gorgeous. And again, July 16th and 17th, you've got just got another wonderful sight. So I'm going to try to see it. Moving on, every moon has a name depending on the culture we're following or the name that we mostly use. This is called a full buck moon, the full moon in July. By the way, driving to the observatory, just before I turned, there were two deer. I'm not sure about the first one. They're fully grown, but the last one was a buck, but just growing. It like maybe had a third of its horns, those velvety horns that they grow. So that's one of the reasons why July is well known, because the guys are busy getting their maintenance. There we go. Now this is more colorful than the map that I showed you in the morning. This is the kind of map I use for night, and I love it because, first of all, it tells you where Venus is. So as you can see, everything is sinking in the west and new constellations are rising in the east. And Venus, like I said, is going to kind of stick to just the evening. And it happens to be under, you can see just above it, there's the question mark part. You can see that it is under Regulus, which is in that constellation Leo. All right. And we're going to talk about most of the bright stars you see. These are really for summer, which can be considered kind of boring, and winter has those bright stars, and it's just marvelous, brisk, freezing to death kind of thing. But the stars seem to be very bright. Well, summer is turning into something that could be very interesting as well. And these are really bright stars. First, because I know we talked about the constellation Leo. Here, a lot of you will probably know the constellation Ursa Major has the Big Dipper. Now that's in the north, okay? So a lot of what we're going to talk about is a little further south. But finding your way, when you go out and there's all these bright stars, it's like, how do I know my way around? One of the things is Arcturus, which I think a bunch of you may have seen, came here early. That is, again, one of the brightest things you'll see, one of the brightest things in the sky. One way you can say, oh, I know that's not another constellation or it's not a planet, is when you take the arc or the handle of the Big Dipper, it'll point to Arcturus. So that's and it kind of tells you where the center of your night sky is. And, unfortunately, it takes about 9 o'clock before you can actually see anything, which is kind of, a bummer. But anyway, that's very important. And then, actually, this is another zodiac constellation after Leo, Virgo. The only thing, it's a very large constellation, but the only thing you can really see is that one star, Spica or Spica. That's going to be at the end of the long, we call it arc to Arcturus and speed onto Spica. And there you've got half of the sky kind of under your belt. So we're going to talk about these. You can see how bright these are And this happens to be what we call the summer triangle. Okay, I'm gonna, go over the stars and the constellations themselves. And you see this, what would you call it? When you look at a page, a map, you see the shaded part. That's supposed to be the Milky Way. And the coolest thing is the first time you go to a dark sky site and you actually see it looks very like a big mesh, and you realize, oh, that is the Milky Way. That's what the, the shaded part of the map is supposed to be. And here we go. I'm giving you some names here. The shaded part is you're looking through the Milky Way galaxy. First of all, we'll go over the names again, but if you have a pair of binoculars at home, you don't need anything very fancy. They're like baby telescopes. And try looking at the sky. You can spend, thousands of dollars or a decent pair, maybe from $50 to $100, that where it's made well enough that they've got, the prisms are made, they don't give you a lot of halos and ambient light that's not supposed to be there. But it's like if you look with your eyes and you see eye stars, you take a pair of binoculars, and I have some back there you folks can try. You can see like 30, 40. And this part of the sky is just full of stars. It makes all of this other area look pretty empty. So that is absolutely gorgeous. We're also going to talk about down here. There's actually very low. There's two. There's one or two, especially this one. Scorpius is a constellation that has a very, very large star here, Antares, and the little teapot constellation, which is Sagittarius. I'll mention that. But these three here, the three main stars, make up that triangle. Vega is the star in Lyra. This is the constellation, and this is the star. And then Cygnus, or the swan, and you can see it kind of looks like a bird. Deneb is the main star there. And then again, Aquila, which is a constellation we had not heard much of. Altair is actually the star there. And this really helps you find your way around that part of the sky. First thing we want to do, though, is this is Hercules, and this is actually sort of like the geometric figure here, and on the side is something called a cluster, a star cluster. And some of our people, Mary didn't go into it before, but we usually point out that all these pictures here are taken by our people. You don't really need anything except a decent camera and then some advice from our members, especially because they love passing that information on. That's one of the perks of being a member. And then a computer, a set of software that will stack images. Every image you take takes more and more and more and more light. So a ton of images, and then stacking them, and then fine tuning them. So this is absolutely gorgeous, and a lot of people love to get the Hercules cluster, which we will talk about. There you go. It's got some of these things have cute names. I like Hercules cluster, cluster of stars. M13, common spelling. And actually, there was a Frenchman called Charles Messier who did a lot of cataloging stars and deep sky objects. So we use that to make it a little easier, if less personal. And that cluster is absolutely gorgeous. It's like like a starburst pin, I guess, a diamond pin, you could say. But people love to look for it. when they go and see stuff in a telescope. And astrophotographers love to photograph it. So Mark is one of our members. So I wanted to show that. And they will probably be showing you here this month to see that cluster. Going back, we're going to go to the left now, and there is that triangle I told you about. And they're basically the first bright stars you see overhead mid-July, except for that Arcturus, you know. But you'll always be able to see the Milky Way arc, or I'm sorry, the I'm sorry, it's Friday. I've used all my words. Yeah, the Big Dipper, the arc. It'll show you Arcturus. But other than that, these things are the ones that come into view, and they really are fascinating in their own way. You'll see that Deneb on the left there, the end, Alberia was actually a double star that has two colors, and if somebody clever up in the domes operating the telescopes can resolve those colors. That's one of our special skills. But blue and gold, to have stars like that together, and stars do have colors. You would think that the ones that are blue are icy cold, and the ones that are redder, we say red planet for Mars and red star. It's more like flesh color, but actually reddish stars are at a later point in their life, and they're starting to swell, and they're kind of cooling down. So actually a red star is cooler than a blue star or a blue-white star. It kind of goes, blue, white, off white, vanilla like our sun, and then, your red giants. So we'll talk about all of them later. And then the first one we're going to talk about is, do I have this? Yes, Lyra. Now the shape is sometimes, let me put it back because you can sort of see, it's very tiny here, but it does sort of look like a heart. Is parallelogram the correct geometric word? Okay. I'm an English major. You do the math. Anyway, that was on a shirt I gave my youngest, who was an English major. It's sometimes it's called a heart. Sometimes it's called either an eagle or a vulture, depending on the myths and the representations surrounding stargazers the world over for ages. And its main star is Vega. And this is a wonderful, wonderful example of when you look with binoculars. Yeah, you won't see all of them, but you'll see quite a few stars. But you will see an extremely bright one. You aim for where in the sky you think it is, and when you hit it, you know you've hit it because it's so bright. And actually, off to the left, you have these two little dots, which are particularly charming. That's one of the deep sky objects I first got interested in. And if you see over there, it's called Epsilon. The actual nomenclature is actually Epsilon Lyrae, and it is not only two stars, but each of them are double stars. If you really resolve and get sort of the real-time full view of how it goes, you need something pretty special to separate them. And when you look up the millions of light years between these things, you realize how massive, and astronomical the distances in space are. I mean, it's just amazing. The cool thing is that anybody who has watched Contact will realize that Vega is a star. They were saying that they were getting signals from Vega, probably a planet somewhere around Vega, or maybe because, without spoiling the movie, maybe it isn't so much a physical place where people can stand as the direction in space. But the cool thing about Vega is that once every, what is it, um, 32,000 years or so, we do what's called precession. We go around, we're tilted on our axis, we go around the sun, but we also wobble, kind of. So when you're trying to find the North Star, and the North Star is all we talk about in our lifetime because that's been our guide, but it hasn't always been the guiding, North Star, North Star. And it's actually going to, if you can see this, this is where we are now, around 2000 AD, and then 4000, there's another very bright star here, which is Vega. So in 14,000, we are going to have another North Star, and it is very big and very bright. Vega is one of the brightest stars in the sky. The actual North Star is not very bright. People really expect to see that it's, to us, one of the brightest stars in the sky, and it actually isn't. No offense. You can still make it out, but and then it's actually going to go to Kuban, and then no. But anyway, that's something else that's kind of cool about Vega, which a lot of people didn't know, and Lyra, which is sort of a nothing constellation, is anything but. The other thing is that there's a beautiful deep sky site in the parallelogram here between these two stars, and this is another Messier figure, Charles Messier, M57, and it is called the Ring Nebula, and this is another thing that people who are doing astrophotography love to get a good picture of. And the coolest thing is, it's almost like a smoke um, ring with a dot in the middle, and then Wayne here. Actually, one of the first people I knew who was doing astrophotography, this is maybe 20 years ago. He was almost 80. He was just a great guy, but he had a little observatory in his backyard. He lived in West Orange, where Edison lived and had his laboratories, and he took these pictures. And now Wayne is somebody who is with us, and he does a lot of good astrophotography. So I wanted to find the latest, the most recent Ring Nebula that our people had taken a picture of. And the cool thing is, this is part of, it's called a nebula, and it's really not the right word, because when we think of the nebula, all the dust and gas, kind of a nursery for stars, when we look at the big nebula in Orion, and that's where stars are born. This is actually towards the end of the life of a star. And let me show you a star like the sun, because this was not a big star, and we are not considered a really big star. So, for certain masses around the mass of the sun, what we do, we don't go supernova, and what we do is, now this is our lifetime, so we're a little over 4 billions a year, so don't worry, nothing's happening tomorrow. But it's gradually warming as opposed to being hot. So it's kind of cooling in a way. And it swells. And then at some point, you get a red giant, and then it throws its, what would you call it? Like the shell away, and you get what's called a planetary nebula. And this is catching uh, our sun at that point in its life, as is the Ring Nebula. Okay, and then we'll probably just settle into white dwarf. So that's very interesting. It's kind of a great way to learn the life cycle of stars like the sun. Now going back, we're going to do to the left of Lyra and the Ring Nebula and Vega is Cygnus, and that is another gorgeous constellation. Deneb, as you can see, I love to look up how big these stars are compared with the sun. And it's so fun to see this, see how big Deneb is, and see how little the sun is. Okay. And Deneb is an Arab word. A lot of the names of constellations, and especially stars, are Arabic because they were people who had an extensive and rich history of stargazing, as well as China, that whole area as well. So now Algeria, like I said, if you really good, you can get to resolve it into two different stars who have different colors. It might not be older, but it's older in its life. And this is at the beginning of its life. So that's something people love to do. They'll be doing that all month. There are some nebulas here, the mixture of gas and dust that give birth to actual stars. And the universe is a very busy place. There's all the stars being born and dying. This is so cool because it looks like a pelican. And one of our people, I don't know if Dawn is with us tonight, but she is really one of our premier astrophotographers. And you can, like I say, you can actually learn how to get pictures like this. I mean, this is absolutely marvelous. And where it is, Pelican Nebula is on the left there. I like to show where these things actually are in the constellation. There's something else, the Veil Nebula. Look at that. That's another one for Wayne. And the Veil Nebula, down towards the bottom there, that is absolutely gorgeous. This doesn't have an M number. There are other, because we've discovered so many deep space objects, there are objects that are given numbers in a new general catalog, and NGP is the what would you call the designation. I'm trying to say the initials, but I shouldn't come up with new words. Thank you. Yeah. So thank you. Good old 6960. So there it is. Also, this is pretty, Wayne just brought this up on his Facebook page. He's still working on it, so I cannot tell you exactly when he took the original picture, but he's still developing it. There's something called the Fireworks Galaxy, and that's an NGC 6946, and you can tell very obviously why it had that, why it's got that name. And here, the funny thing is, I try not to use Wikipedia, but you know what? It's good for some things. They always tell you where in the constellation a lot of stars are, and where in the sky the constellation they're talking about is. It's amazing how many things I tried, sites I tried, that didn't actually tell me where in the swan is this. This is actually between, this is the swan here, this is between Deneb on the bottom and Cepheus, who is actually the father of Andromeda and husband to Cassiopeia, but that's another that's another whole story. But it literally is on the cusp between both of those constellations. So that is just totally cool. And thank you, Wikipedia. There it is in a pretty background. And there you have it. You need a telescope to see that, but anyway, Aquila is something else that nobody's ever heard of, but it's got a star Altair that is part of that. Let me go back. That is part of that. There it is, right down there under Cygnus. It's part of that summer triangle. It does have some sort of, I guess, grade B movie cred because it's apparently one of the planets around that star. It's mentioned very briefly. That was the forbidden planet of Leslie Nielsen and Anne Francis and the robot. Anyway, but this is a very nice. On the left is one of the prettiest views of the summer triangle. Helps you locate where you are in the sky. And now, one of the things about Aquila, it doesn't show up a lot of times unless you're talking about the triangle. There are some quests that astronomers each month try to compete with each other or just have a good time locating a comet 169P/NEAT. And actually, this Astronomy Now site has charted where it's going from the end of June to the beginning of August. And it's pretty much starting with the Kiva here. And then heading up towards Hercules, which we talked about. So anybody, you can Google if you're really interested in catching that. Again, something like that, you do need a telescope, and it's not something that's going to really move on you. Each day, it'll move a little more. But some people just love to catch that. That's also the parent body of. There's a southern hemisphere super bright Alpha Capricornis meteor showers at July's end. And if you're in the south of the United States, you can probably, there was an article today about Kentucky, people having a great time looking for that. It's not a huge shower, but what meteors there are extremely bright. So, it's wonderful for them, but it's really nothing we could do. Right now, you could track the actual comet in the more northern area of the sky, just as they show it here. Here's just some nice pictures of Vega, Deneb, and Altair in various guises. You can see the triangle. It's in that whole Milky Way section. Don't forget to aim your binoculars in any of that area. And when you get all the way down, you follow Deneb and Altair, way at the bottom is actually the center of our galaxy. It's a little low on the horizon, but it is very cool. And down at the bottom there, Antares in the constellation Scorpius, that is another, excuse me, Mars isn't supposed to be there. I was supposed to take that out. That is from another month. Pardon me, I hope Mars will be back soon. But I wanted to get to Scorpius there because it really, well, Sagittarius is just before it. A lot of people know that as the teapot constellation. And then you keep going, to the right here, and the galactic center is right by one of the, I guess you could look at it as a teapot, and the actually the steam coming out could be the wonderful shady parts of the galaxy. But the galactic center, which is really a star called Sagittarius A, is there. There's Sagittarius. It's also known as the Archer. depicted as a centaur, and aiming an arrow towards the heart of the neighboring constellation Scorpio, which is directly to the right of it. What I love about Scorpius is you can see how low it goes, but I can see, I have a, um, I do a vacation way up in Sussex County in the mountains, and usually in the July area or the time frame, and I can really see low. And that part of it's supposed to be like a scorpion, um, but that top is almost like I don't know what a fish hook. But those are very, very really, really beautiful sight. There's also apparently a whole bunch of double stars they just discovered today while studying it that I'm going to try to look at with binoculars. You know those two little dots that you found when you saw Vega and those two little guys there? That is, when you find something that you're looking for, it's just because you're into it. It's just very entertaining, and you want to do it again the next night. And it's just the feeling that you can do it. Here's, I'm sorry, 3 Sagittarius, which is the center of a galaxy, sort of outside looking in, even though we're in it. Antares is one of the brightest stars in the sky. And like I was telling you, it's dying. It's an orange, flesh-colored red star. And the name, almost like anti-Ares, he's the Greek rival of the Roman god of war, who is Mars. So this is a rival of Mars. See what we did there? It's at the end of his life, and it's cooling off. It does twinkle because it's very low in the atmosphere, and it is one of the stars in the sky that you will see twinkling more than a lot of others. It just really is like all this going on. It actually does seem to have other colors in there, but it's a great naked eye sight. And you see how much bigger that is than our sun? You see, at the if it were put in our solar system, it would go past Earth, and it would be by the orbit of Mars. We just, it's so huge. The Perseid meteor shower is considered by many people to be an August shower, but like a lot of showers, they start about a month before. So mid-July, try to take a look at the constellation Perseus, which is right below Cassiopeia, that W. A lot of people can find that in the sky. It's in the north. It's by the Big Dipper. The Perseus is obviously a set it's a constellation set among stars. The meteor showers actually come from just beyond or within the solar system. So they're not as far out as the stars, right? Stars don't begin for millions and millions of light years, but it's the direction of that constellation. So that's why they're called Perseids. We should be in pretty good shape for the end of July. It really should not have a horrible moon to get us to wash it out. We love the moon, but we don't like it to wash things out. This is at the end. I just want to tell you something that my mom put in the card when she heard that I was into astronomy. Kind of midlife, not crisis, but hobby. And she said, "May the stars shine all around to keep you amazed." And it really is the way I think we all feel. I mean, she's Irish born and obviously has the gift of poetry, a la Yeats and Joyce and all those cool people. But I really like to end with this. And then here are some of the people who who either helped me with all of this or to the right there on top, there are our 3 astrophotographers who are featured. And I certainly hope there's something to look at, but thank you so much for your attention. Good night.